the transformer is not sized correctly. The secondary side of the transformer is feeding a 600 amp main circuit breaker distribution panel. This implies that the transformer should be capable of supplying 600 amps at 480 volts. To determine the necessary transformer size, we need to understand the relationship between apparent power, voltage, and current. The apparent power, denoted as S, is measured in volt amps, or VA, and often expressed in kilovolt amps, or kVA. The formula that connects these three quantities is S equals V times I, where S represents the apparent power in volt amps, V stands for the voltage in volts, and I signifies the current in amps. In this particular scenario, we have a voltage of 480 volts and a current of 600 amps on the secondary side. To calculate the required apparent power, we simply multiply these two values. S equals 480 volts times 600 amps. This calculation yields 288,000 volt amps, or 288 kVA. The existing transformer has a rating of 300 kVA. While this value appears larger than the calculated 288 kVA, there's a critical aspect to consider. Electrical codes and standards often mandate that transformers be sized to accommodate at least 125% of the continuous load. This practice ensures that the transformer operates within its thermal limits and provides a safety margin for future load growth. To apply this 125% factor, we multiply the calculated apparent power of 288 kVA by 1.25. This gives us 360 kVA. This new value of 360 kVA represents the minimum recommended transformer size to adequately handle the 600 amp load with the appropriate safety margin. Since the existing transformer is rated at only 300 kVA, it falls short of this requirement. Therefore, the transformer is indeed undersized for the application. Replacing the existing 300 kVA transformer with a transformer rated at least 360 kVA is the correct action. This ensures that the electrical system operates safely and reliably, and that the transformer isn't stressed beyond its design limits. In summary, the transformer is not adequately sized because it cannot handle 125% of the continuous load on the secondary side. A 360 kVA transformer would be the suitable replacement.